The electrical system that we may consider is quite basic, has a resistor. So this is the schematic for resistor. Resistor has the resistance, yeah, R. The voltage across resistor we label as VR, and then the current pass through the resistor. So the governing equation for resistor, we have voltage across equal to current multiplied with resistance. Okay. The second one is capacitor. The capacitor, this is schematic, that's a double vertical line. It has the coefficient of capacitance C, the current passed through the capacitor, and the voltage across the capacitor as we label as VC. So the governing equation, the current passed through the the capacitor is equal to I coefficient capacitance and the derivative of the voltage across the capacitor, VC, ICD VC. And the third one, we have inductor. This is the schematic like a curl. Current pass through the inductor. It has the coefficient of, we call it as inductance, L, inductance, and then voltage across the inductor, VL. So the governing equation for inductor, the voltage across inductor is inductance multiplied with the derivative of current. Okay, that's it, the three components that we may consider in our system. On top of this, we have to look into Kirchhoff law. Kirchhoff law, CHOFF law for current. Okay, so assume we have a junction, the current into junction, let's say I, current coming out from the junction, let's say this is I1, this is I2. Okay, I2. So the summation of current that coming out from a junction equal to the current that going into the junction. So in this case, I equal to I1 plus I2. Okay. And then the second one is the Kirchhoff law for voltage. Kirchhoff law for voltage. It says that the summation of voltage in a loop, okay, in a loop should be 0. Alright, these are the laws that we may consider in dealing with electrical system. So let we look into simple example. Let's say we have a system with a supply voltage VI, and it has a resistor here, it has a capacitor, and it has an inductance here. Okay, so plus minus. So the resistor with the R resistance, C capacitor, and L inductance. Then we have the voltage across resistor VR, voltage across in capacitor we see, and voltage across inductance VL. So we have current pass through. So let's say our input is, we're going to see how does the input related to the output. Our input is VI, supply voltage, and our output is V0. So V0 is here. Alright, V0. Alright. First, we derive the equation relating to the voltage in a loop. So we start with the supply voltage here, VI. Summation mean the other voltage, the summation should be equal to VI. Or in other words, we can write as VI, because VI in this direction, alright, in the clockwise. So the rest voltage are in the anti-clockwise. So it can be minus VI minus VR minus VC minus VL equal to 0. That's the equation number 1. The individual voltage VR is IR, VC is I CD VC, and inductance VL equal to LDI. Question number 4. Notice that the V naught is the one that we want to determine is actually VC. So V naught equal to VC. Okay. So let's say put number 5. So now we may start derive the block diagram by using all these equations. So we must be sure our input is VI. So we start with VI here on the far left. So by using equation number 1, number 1, VI minus VR, okay, or VI minus VC. You can put it in either way because this is algebra. You can start the minus. No problem when you start with VR, VC, or VL. Alright. In this case, I started with VL here, minus VL. Again, minus with VC or VR. So I started with, followed with VC. And then this is the result, the output is VR. Okay. So VI minus VL minus VC equal to VR. So from VR, we want to derive I. Alright. If I able to derive I here, I can use I for the next following equations. So VR, how to get I from VR? So equation number 2 is telling us, so you have to divide VR by R. Alright, divide mean 1 over R. Okay, 1 over R, the output is I. Okay, because this is the block in series, you just multiply. The signal, the arrow that coming in VR has to be multiplied with the block in series. So VR multiplied with 1 over R2, sorry R, equal to I. So we already used equation number 2. I is, you can see I is stated in equation number 3 or 4. You can proceed with this equation number 3. Alright. Remember at the end we want to derive VC here. Alright, VC. So VC. So this, how you can get VC from I? You put another block here, equation number 3. Okay. You divide by CD. Alright. I, you divide by CD. The output should be VC. So that's it. The output of our system VC, or in this case labeled as V naught. Okay. VC equal to V naught. Now the remaining these two signals should be we link into their source. So VC, this VC is coming from the end down there, and VL still not being used. Now we use it. You find I you multiply with LD. So you take it from here, multiply with LD. The output should be VL. So this is our block diagram for this electrical system.